I've been working with Wipro since last 6 years and contributed to NLP, NLU from past 4 years, and been working in computer vision in past 2 years. So I have a diversified portfolio altogether. And so that's a very brief about myself. Let me share my screen. So today we'll be actually discussing about conversational AI platform. So most of you might be knowing this, may not be knowing this. So conversational AI platform is something which is the future of almost all the technology stacks. Okay. So today or tomorrow, everything is going to be automated and there should not be any manual intervention. So what we want as a human evolution, if you see in the past few years, right, human evolution has already taken these steps to get everything automated, which is not more necessary. Just taking an example, okay, the business process services, right? Like when you call your customer care, right? So they are pretty much struggling, okay? They are attending so many calls on a daily basis. They are attending so many interviews, so many challenges they are facing, right? They need to be calm, right? Even that customer might be too rude with them, but the support team should be, the customer service desk should be calm and cool, right? And it is very difficult, right? Because as a human being, we do have different emotions attached to it. Okay, so it's not that every time they can be calm, right? So what we need now is we need a serious change in our process and system. So what is that serious change? How can we replace that? Customer service is required, right? For an example, you want to order something from Amazon or Flipkart or Walmart, okay? You need some help, right? That point in time, you will just connect to the customer support desk, right? That, hey, I need a help. I have an order. I want to reschedule that order, or I want to cancel it. I want my payment later on. So all those sort of queries you will be having in real time. And most of the time, what happens is you are actually frustrated of some issues. And while you are frustrated, you are contacting the customer support and you just exhaust all your frustration to that particular lady or particular person, right? So that's what happens in the current industry. Now, how can we solve those sort of problems? So not only that, that is one of the scenario where conversational AI is required. The other scenario is, let's say, you have those channels where we don't have a support based upon calls. Okay, there might be many companies, specifically the enterprise level company. Okay, they don't entertain calls. Okay, so it's most on the technical companies. Okay, not like end customer companies like Amazon, Google, not like that. Okay, they are basically technical companies. Like for an example, Dell EMC. Okay, then example is NetApp. Okay, so they are actually into the engineering business. Okay, so they design the arrays, they design the cloud infrastructure, they design the network part. Okay, they are selling the cyber security and all those stuff, right? So in those cases, we don't have any call mechanism directly. Okay, until unless it is highly required. So what that ticketing system is been preferred. Now you get so many tickets on a daily basis. Okay, a small issue is there, people are raising tickets. You get hundreds and thousands, probably lakhs of tickets at the end of the month. And you need a resource who can work on those tickets, right? And that resource will be working on the same ticket again and again, again and again. And at the end of the few years, he or she might end up dropping from that job because he's doing the same stuff again and again. Nobody likes to do that. So what we have seen that anything which is tedious, anything which is we need change, okay, has been transformed, has been removed, or has been elevated using technology. Till now that happened from our previous histories, right? So conversational AI platform already been started. Okay, it's not new. You have Alexa at your home, which is helping you to switch on your TV, switching to respective channels, switching on your mobile, switching on your uh, what you said. It can do anything, right? So Alexa is, but specific to a limited task. Okay, not like a full-fledged task. Okay, it's kind of a limited task that it can be. It can help in doing. Similarly, you have Google Duplex. Okay, so I will come to the Duplex later on. I would suggest each and everyone to watch Google Duplex video. If you haven't watched, you don't know it, just go to your YouTube, have a watch after this session, have a watch of Google Duplex. Okay, you will be amazed because the technology, the improvement that happened in the AI. Okay, Google has really transformed the business. Okay, they are actually transforming the business, and in future they are going to come like hell. Okay, so similarly, there are no such competitor as of now in the market comparative to Google Duplex. Okay, so it is also it's one of the strongest AI platform, conversational AI platform, and even Alexa doesn't come near to Google Duplex. Even your Apple Siri never comes to Google Duplex. So it is very strong. It can book you up. It can book a hotel. It can book your appointment for a hotel, appointment for your salon spa, appointment for your dental doctors. Okay, anything. Okay, any use case you give it to Google Duplex, it can do it. And the most funniest part is nobody can understand that the other side of the Duplex is actually calling for an appointment, okay, to an hotel, and nobody was able to understand that it was a kind of a robot speaking with them. The tone, the language, the way the model has been designed, the AI model has been designed, it looks very scary. Okay, nobody can understand that it's kind of a robot which is actually doing it. It's a script which is actually doing it. And it was very amazing thing. Okay, you can have a look. So in our next few generation, okay, it is going to get it evolved. Generation in the sense, we into the IT generation, we take it as 5 years. In 5 years, something new will come. Okay, so that is the generation. Don't think that it's your generation of 100 years. No, it's basically only the 5 years in IT we have it. So every 5 years, we can see a lot of traction happening. So similarly, if we see the technology stats of AI, there is a lot of improvement happened in last 2 years. A lot of improvement happened, and we never expected that those sort of improvement will come. In upcoming next 2 years, even we don't know that what sort of improvement is going to come. AI is going to build poems. They are going for artistic challenge. Okay, they are drawing, they are painting. So a lot of important and funny stuffs they're doing it, and it's not about generating poem. Doesn't make any business out of it. But what we are focusing is how toughest problem it can solve. Generating poem is one of the toughest problem. Not everybody can write poems, right? But if your algorithm can write poems, you can understand that it is much smarter than you. So this is how your environment is moving towards. The conversational AI platform is a need for all these companies, okay? For all the infrastructure companies, for all of these companies, it is one of the important parts. So all these customer service desk in some years will be converted into these conversational AI platforms. So industry has a very big demand on NLP, NLU, and NLG technologies, and very big demand is there. Currently, still it has not been implemented in a wide manner, but in upcoming few years, it will be like roaring into the industry. Now coming, I just given a very real-time example, okay? Now coming back to what will be our agenda for the day, okay? So we'll be actually building, and we have actually designed a AI platform, okay? Conversational AI platform. So it's not been, you cannot write a code in few hours. It takes a lot of time to build that code, and a lot of time to train that model, okay? So what we'll show is how to build that. What are the steps? Okay. Like in my last webinar workshop, I tried to deploy it and show you that the live coding we did it, right? So this session, maybe we will be not doing the live coding, but we'll get a direct insights, okay? Because it takes a lot of time to build those sort of conversational AI platforms. So you can actually understand each and every steps, each and every part of the bits and pieces of the code, and you can implement that, okay? So that will be our understanding, okay? And then we will relate with the current industry problem. Industry problem I already mentioned, okay? Then mapping linguistic features with NLP and NLU. Okay, now there is very different approach that we do it in terms of solving the language problem. So all in this current meeting, like we have so many people, okay? I think we have 18 or 20 people. Yeah, 18 people. We are very diversified, okay? Especially from India, we have so many languages. We deal with. So even you just have a particular language, you go to the remote villages, the language model, the way we speak that language changes. Similarly, in other countries, okay, language is one of the difficult tasks to handle. Vision is fair enough, right? Dogs from India and dogs from America will look almost similar. So vision is not facing that ambiguous problem, but language is very ambiguous, okay? So we will understand like how to deal with these languages. Similarly, we'll understand some deep learning concept. I know this might be something repeating in my previous workshop for those who have attended. For those who have not attended, for them it will be new. Understanding architecture of LSTM, and we'll actually add something more on LSTM. Okay, with LSTM we cannot solve the problem, but we have something more to add on LSTM. And then how to get it implemented using Python, the chatbot. And it's like beyond chatbot. Okay, now we are actually dealing as a chatbot. Chatbot has been there for years, but earlier the chatbot was developed based upon certain rules, based upon certain keywords. So now we don't develop chatbot based upon keywords. We develop chatbot based upon the understanding, the way it expresses. That is what we take it. Okay, so this is our agenda for the day, and we'll proceed with the agenda similarly. So let's move. So introduction to conversational AI platform. So we already had discussed almost even in cars nowadays, we have a conversational AI platform. Hyundai cars, okay? So you will get to see the AI platform over there. You can speak with the car. So most importantly, you can also Google Tulip. You can also Google Google Tulip. Okay, so this is one of the you can just watch this video introduction to introducing Google Tulip. Okay, so this is very interesting thing. Your plant is even speaking with you, whether it needs any rain, whether it needs any water, whether it needs any nutrients, whether it needs any sunlight. This project has been there in Netherlands. Okay, and this is one of the best application that Google has developed. Okay, so Netherlands is one of the amazing country, and we have a lot of tulip flowers coming from Netherlands. So you can see that all these tabs are connected with a bunch of tulips flower, and they can say that when they need oxygen, whether they are lacking any oxygen, or whether they are lacking oxygen in the sense the NO2, sorry, CO2, okay, whether they are lacking nitrogen, okay, for their nutrients, whether they are lacking carbon dioxide, so whatever it is, all these are being communicated using this Google Tulip program. Okay, so this is one of the amazing stuff. Okay, then you have Google Duplex, okay, which I was talking about. it exactly speaks like human. You never understand, okay, how does it speak? Okay. And Google has done a very hard job in making this particular platform. Okay. There are multiple things to it, speech recognition to it, and you have conversion from speech to text. Then you have to understand the text, right? Okay, awesome, thanks a lot. So what does it mean? You have to understand that as well. So a lot of different platforms are already there, but only with Google. Uh, and most of the companies are now trying to get it deployed and developed, okay, for their organization as well. So there is a lot of demand in conversational AI platform. It's beyond chatbot. Okay, not only just you need to type and it can communicate. It's like beyond that. And most of the problems like customer service desk problem, where there are so many people engaged, okay, and they are also just frustrated, okay, with a lot of calls coming in, with the different type of people they are interacting with. All these people have a different type of moods with them, right? Somebody might be very good, somebody might be very angry, okay, because of the service, because of the thing happened with them. And it's very ambiguous in nature. The work is also very difficult, right? You have to be very calm and cool, given that what the customer says doesn't matter. So that is how the problems can be addressed using this conversational AI platform. So this is how a very broad view. This is the neural network which is handling all these conversation, and the speech and all those things are being provided to this particular neural network. And neural network actually predicts that what should be the next sentences, okay, and what should be the, given that let's say you said like, okay, what time for, okay, for what time. So let's say if somebody is saying you are booking a kind of a reservation, you are booking a table at a hotel, okay, a restaurant for a weekend plan, and you want to book it for 7 p.m. let's say. So you have told that I want to book a table, okay, it has to be reserved for this date. So then Google might say, okay, so for what time you are looking into it, then you can say that, okay, for 7 p.m. Or it could be the vice versa. It could be the platform which is actually booking for you. Okay, it could be the platform which is being sitting on the restaurant, or it could be the platform which, it could be a platform through which who is booking in on behalf of you. Okay, so that could be the case. Okay, it could be vice versa, because now assistant is with everyone, right? So hotel guys might have an assistant, and it's you also have an assistant. In few years, only assistant will speak with assistant. That makes more enjoyable conversation, right? So that's how the future is going to be. So you say that what time you are looking for, your assistant says that 7 p.m. Again, by checking your calendar and by checking your availability, it says that 7 p.m. And like that, you book your hotel. Okay, you can book anything. You can actually interact with Amazon. You can interact with Flipkart, Walmart. Okay, anybody. So this is how the AI platform is going to be in terms of conversational AI platform. It's very interesting subject altogether, and it is a bit hard. Okay, so it is you need to be very patient, okay, while learning this particular subject. Okay, you need to have a lot of patience. It is not that easy like machine learning. Okay. So these are the foundation, okay, that we actually follow in our training. And the current stage of AI is over here, okay, at this stage. Before coming to this stage, you have to undergo all these steps, okay. So starting with tokenization, lemmatization, stemming, stop word, bag of word, TF-IDF, unigrams. So these are some pre-processing steps, okay. After pre-processing, then comes your learning steps, okay, learning from the data set. And this is basically, let me change the color. And this is basically your understanding and generation. U or G. Natural language understanding and then generating based upon the understanding. Okay. So let me take one example. Fill in the blanks example. In school days, we used to have a question, right? Fill in the blanks. You have to fill the blanks based upon certain context. In now, AI is actually solving those problems. AI is solving the fill in the blanks problem. In school days, you have some given context, some paragraph will be there, right? From that paragraph, you need to read that paragraph. And from that paragraph, there will be certain questions. In our English literature, okay, we used to have this sort of questions, right? So over there, what we used to do, we used to read the paragraph and then we used to answer the question. AI is now solving those sort of problems. So these are at this understanding and generation stack. This is more about learning stack. And this is more about pre-processing. Pre-processing before we learn and before we understand. Okay. So there are 3 levels. This by default takes a lot of time to understand each and every concepts. So today we'll try to explain you into a more naturalistic way rather than going into too deep towards mathematical models and all, so that you can understand and relate the algorithm from the current scenario and with the mathematical concepts. Now, starting with this pre-processing, at the pre-processing, what is basically pre-processing? Pre-processing means, let's say we have a paragraph. From that paragraph, there will be so many words. Now, not every word is important, right? Okay, not everything is important to you. There will be some specific names, there will be some specific locations, some specific date and time, which is important to you. Rest of the paragraph, rest of the words may not be important to you. So you need to understand that which is important and which is not important. So for that, what you need to do is you need to pre-process it. So pre-processing include removing of unwanted words, removing of unwanted words, removing of grammars. Grammars in mathematical sense doesn't make any solution, okay? So mathematically grammar is something which has no sense. So for an example, I want to say, for an example, I want to take, I want to study AI let's say this is the sentence. I want to study AI. Okay. Now here, this two doesn't make any sense. Doesn't make any sense. Mathematically, what is important? AI, study, and want. Even I doesn't makes much sense. Because you need to understand the intuition. Okay. You need to understand the intuition of the sentence. So want, study, AI. These three things are important. Only we'll take these three things and we can actually compute that what is the topic that we are talking about. We are talking about I want to study AI. Similarly, if it is a very long sentence, there will be like I want to visit temple from this time to this time on this date. Okay. So only important is visit, temple, date and times. Rest all the words are not important. But in a human mind, grammar is important because human mind works in a different way. For human mind, without grammar, you will be not able to understand. You cannot frame the sentence and you will be not able to understand that what somebody is conveying to say. So both works different, but there is some relativity between human mind and the grammar. Human mind and the machine learning models and deep learning models and AI.
I believe it's okay. There may be some people, communication opportunities that
Can somebody go on mute?
Thank you for your answers. And you'll get to know, was it a leading question? Was it a good or not question? As we go through and seeking the support of
So any question for me or any question for me? Okay. So
yes, just a quick. I don't know, is it a question or a note? I mean, based on my my analysis, which I've done in the past, when it comes to text pre-processing, this is the most tedious and dirty job, to be honest.
yeah, absolutely.
So yeah, so I see that it's even to 3 steps here. So there are 3 steps till you reach the almost the complete text processing, right?
Yeah. So this is more about NLP. This is more about NLU, and there is a little part of NLG. NLG is something which is still in a research state. Okay. So we actually didn't land it in a full-fledged way in solving the NLG text generation problems. Okay. Like we can generate a text, a single text, 2 text, 3 text. Okay. But we cannot generate a full-fledged sentence yet. Okay. So still it's a kind of in a research state. But with this NLU and with this a bit of NLG, okay, we could be able to solve this sort of problem very easily, like conversational AI problem. NLP is more about just cleaning the text, okay, reprocessing the text, getting the meaningful words, okay, and those are all about like getting the meaningful word, okay. It's kind of a pre-processing that happens before this NLU.
What does NLU stand for? Natural language understanding, or?
Yeah, natural language understanding.
All right, fine, thanks.
Yeah, so NLU stand for natural language understanding. NLG is basically natural language generation, and NLP is pre-processing. Anyway, this is all about the foundation. So we need to go through this foundation to get a complete understanding of how these conversational AI platform works. But today I will try to give a brief. Almost I will touch each and every point, NLP, NLU, NLG, and you can have a better understanding like what all the different stuffs being doing. Now coming to the next slide, basics of NLP. So what we do here is very basic stuff. Okay, this is more into the pre-processing. So any text we take, like the cat sat on the mat, any text, this is a text, this is a sentence. We take this sentence and we split this sentence into single tokens. We call this as tokens. So these tokens are used further for more amount of pre-processing, which I will understand slowly. It's very simple, just split by space, split by space. Okay. Now, again, there are different type of tokenization. Okay, there are tokenization based upon sentence. It's called sentence tokenization. Okay, this is basically word tokenization, split by word. Let's say you have a document. There are few documents, let's say. So each and every document is having, let's say each and every book is having so many sentences. Now, before jumping into the word tokenization, you should always do sentence-based tokenization, means splitting each and every sentences, and from each and every sentences, split the words. It's very easy problem, which can be easily solved. But where we actually use this sort of, so NLP, NLU, NLG, one application I just want to explain. It's not only limited to your chatbots and conversational AI platform. Can be used in multiple things like sentiment analysis. Okay, there are many applications. Topic modeling, okay, creating topics, understanding the content of the text summarization, we'll say it as. Like for an example, InShots is one of the application. I hope most of them know, which actually summarize the entire news into few lines. Okay, summarize the entire news into few lines in short. Now this is being done. It's a complete AI application. Okay. It reads the news. News will be very big, but to summarize that, only having the important word is something which is very important, right? You don't have to go to the entire news. So these are some of the application. One of the application is being used by IBM Watson. If you guys know IBM Watson, if you don't know, that's not a problem. So Watson is a kind of an intelligent platform which actually interacts. It's basically does the job of all the NLP, NLU stuffs. Okay. So Watson actually helps doctors to go through multiple research paper in a very short span of time. Specifically, the treatment for cancer is very time consuming, and also treatment for cancer are very difficult, right? Because there are certain scenarios which may be not common, or which the doctor and the medical team might be not aware of. So you might have those sort of patient in your hospital where the situations are not being ever faced. Okay, so in those cases, it is very difficult for the doctors. Might be they need some consultant, okay, to actually interact with. And just a minute. Yeah, sorry guys. Yeah. So in those cases, what happens is we have the cancer patients, might be some rare cases, might be the medicine is not known, given that the doctor is able to identify the problem, but what exact medicine they need to be treated with may not be known, because medical field is very vast field. And nowadays we are applying AI to solve those sort of problems. Okay. So healthcare is one of the niche market altogether. In COVID times, we have already seen. So more lot of focus is going towards medical field. And one of the problem what IBM Watson solves is it helps to go through all the thesis papers, research papers, and figure out the important content relevant to a particular cancer. Let's say the doctor want to figure out something based upon the pancreatic cancer. Okay. Now, in that case, what happens is maybe doctor is not aware of what exact medicine, or doctor wants to know what is the best practice that has to be followed while treating this pancreatic cancer patients. Okay. So in that case, IBM Watson helped the doctors to actually go through all the relevant documents. There are near about 1,000 billion millions text documents, right? PDFs, thesis paper, research paper. So it's very become difficult. Nobody can in this world can go through multiple papers and figure out what is the solution, is whether there is any solution, or there is no such solution. If there is any solution, there might be some notation regarding to this particular cancer type in the research paper. So the IBM Watson helps to narrate and summarize in short that what all the details are there in the thesis and research papers. So those sort of particular solutions can be actually been used by AI. So it is helping the doctor as well as it is helping the patients indirectly, right? Because it is helping doctor, and doctor is able to treat. The earlier doctor used to take 2 to 3 days to decide what sort of medicine can be provided to the patient for rare cases. Now doctor will be able to do it in a day, because the model can actually read, the solution can read through all those books and newspaper, okay, thesis papers, okay, and all those different stuffs, all the content material. Okay. So this is how AI is evolving. So there are many such applications which I will be discussing while going through the entire session. Now coming back to this tokenization. So tokenization is splitting of these words. Next process is stemming. Okay. So what is stemming? Stemming means meaningful extraction. Okay. Stemming and lemmatization. There is another process called stemming is not meaningful. Lemmatization. Okay. Lemmatization. It's basically the meaningful extraction. Okay. I was telling like grammar makes the sentences more ambiguous. Okay. From the mathematical point of view, you can see change, changing, changes, changed, changer, all are referring to a word called change. Right. So what does it mean? It means that even though there are so many different tenses, past tense, future tense, present tense, okay, so many things have been used, but the ultimate meaning of the word is change. Okay, it is just for humans to understand, not for the mathematics to understand. So in order to make a standard word, we use lemmatization. Stemming is basically, it goes by word, okay, word by word matching. Okay, CHAN. So it is basically lemmatized output. If it is a stemming output, it would be CHANG. Now from this, we cannot find out any meaning, CHANG. Until unless we put a E at the end, we can understand, okay, this is change. Okay, this is not a meaningful extraction. So this is called stemming. Lemmatization means meaningful extraction. Okay? Meaningfully, we are extracting the content. So sometimes we use stemming. Most of the time we use lemmatization because it has a meaningful extraction. The next step is, this is called POS tagging, pause tagging. So what is pause tagging? In some of the cases, grammar do helps in identify whether what, like we have a noun, we have the prepositions, okay, we have verb. So these two are very important in terms of English language. Noun and verb, these two are very important. Rest you can avoid it, okay, because noun will be including certain names, okay, certain objects. Verb will be including certain activity. Okay, John likes. So John likes house, street, end. So these are basically noun. John likes, and if you just take noun and verb, then what will be the sentence? John likes house, end, street. Still making some sense. If you remove all the other part, adjective, adverb, conjunction, determiner, preposition, only taking noun and verb will actually help us to figure out the important word. So what scientists have done is, they have actually created a model which is called POS tagging, parts of speech tagging. So what it does is, it actually creates kind of a, it is being trained based upon different grammatical features like noun, pronoun, preposition, determiner, adjective, and it can actually label each and every word with the grammatical features. So from here, if you just pull out the noun and verb, you will be actually pulling most of the relevant words. Okay, most of the relevant word you can easily put it using POS tag. But again, what we have seen, that POS tagging also sometimes lands into ambiguity. Okay, that is one of the challenge. Another challenge of POS tagging is, parts of speech tagging is, it only works for English language. What about other language, specifically the Arabic languages? Middle East, it is very difficult for implementing this NLP and NLU, because it is very difficult, first of all, to break into this sort of text. Okay, this sort of text, and it is very difficult to actually go through creating a mathematical model. There are few companies working, basically one of the company name is called Neural Space. Okay, they are actually working on those sort of model. Okay, so they are actually the diversified portfolio. Okay, they are having a very diversified, they are not focusing on English language, they are mostly focusing on some challenging language like Japanese, Chinese, okay, mostly the Middle East languages, Indian language. India has a wide range of languages, okay. Each and every state is having a different language. Okay. I belong from a different state, I work in a different state, and all the languages are different. Given that we celebrate a single festival, Diwali, sitting at one state, you also can also celebrate Diwali as a festival. Sitting in a different state, you can also celebrate. But both of us have a different language. We cannot communicate better. But still, what I want to say is POS tagging only works for English. So it doesn't work for other language. So this is not a good idea. Okay. And again, it works for English. Then what you have to do it for other language. Then for other language, it is very difficult because over there is no noun, no verb. Okay. There might be, okay, I am not aware, but it is very difficult, okay, to decide like which will be noun, which will be verb, okay. And you need to create your own language model, which is very, very difficult, very, very time consuming. It might take few years to land into this sort of creation of model. So we cannot do that, okay. Honestly, we cannot do that. So that's why we have to heavily rely on deep learning. Okay, I will explain at the end. So assuming that only we are going with English, okay. So the next step is what vector. So what vector, what is this? What vector? What vector is basically converting each and every word into some mathematical notation. To answer you in a plain English, converting each and every word into a mathematical notation. So how does it work? What vector? Let's say cat is there. Cat and kitten, okay, they are the similar thing, okay. So that's why the vector also matches. Similarly, dog is something which is quite different from cat and kitten. So it is having a different vector. So what is vector, by the way? Mathematically, what is vector? Vector is having certain direction and certain magnitude, right? Vector is having direction and magnitude, both, right? What is scalar? Scalar is basically just a single number, which is, let's say, 24. 24 is scalar. What is vector? Vector is, let's say, 24 and 46. So 24 is x, 46 y. You can plot x and y. This is x, this is y. Somewhere, let's say, I'm assuming this as a 24 and this as a 46. Right? So vector and scalar, this is the difference. Mathematically, so what we do is we don't take a scalar value because we cannot represent in terms of x and y. There will be no direction. So that's why vector has a direction as well as it has a magnitude. So that's the reason each and every word is being converted into what vector. Each and every word is having a vector. So you can see cat and kitten is the same composition. So that's why they are having a similar vector. Whereas dog is much more near, both are animals, okay, much more near, belonging from the same group, okay. So that's why the distance is very less. Direction is also same. Whereas house is something completely different from dog, cat, kitten. It is completely a different object. So it is also being listed quite far away, okay. The distance is very far. So that's what word vector helps us to understand which word is relevant, which word is meaningful, and which word belongs to what sort of group. You can also refer it as a clustering in terms of machine learning. But in clustering, the algorithm works in a different way, whereas word vector algorithm works in a different way. It basically works with vectors. Okay. Now coming to this particular topic, each and every vector is having certain value. And the size of the vector doesn't depend on this feature. This is just an imaginary explanation. This is just an imaginary explanation. It is being computed mathematically with the different formulas. Okay. So what vector formulas are there, which being mathematically computed. So don't go by this particular thing. This is just imaginary features just to make you understand. Okay. But it is being mathematically computed separately. Okay. And from there we get this vector. and there is no limit to the size of vector. Okay, ideally these vector sizes are basically 512, or it can be somewhere around 1024. Okay, each and every word is having these many numbers. Okay, so there is no such limits to it, right? So why there is no limit? Because it depends on your how many words you are having in your system, which will be converted into vector. And there are billion and billion of words. Okay, so there are billion and billion of words which are actually being converted into this word vector. So that's why to differentiate each and every word, and also to have some relativity between the words, we need this word vector. Okay, so fine. So this is all about the basic NLPs. Okay, basic natural language processing. The next part is basically nothing but will be directly focusing into this intent and entity relationship. So till now, there are many more things there in our pre-processing. Okay, TF, IDF, and many more things are there. But I'm not going into too many details. We'll be only focusing to our today's agenda, which is conversational AI platform, where we don't use those pre-processing. We only do these sort of pre-processing. Mostly our energy and our time in building the conversational AI platform gets invested in this intent entity relationship. Now, what is intent entity relationship? It is basically nothing but what you are trying to express. For an example, I want to buy a mobile phone, and you can say that I want to buy an iPhone. Okay, you want to say that you can also say that I want to buy a Mercedes car. Okay, you can also say, so these words, I want to buy, what is expressing? You are expressing that you want to buy something, right? There could be, I want to reschedule my order. Okay, I want to reschedule my delivery date. I want to reschedule my date and time. Okay, I want to reschedule my address. Okay, so all those things explains that you want to reschedule it. So this is called an intent. What you are trying to express. You want to buy something, you want to cancel something, you want to reschedule something. These are being referred as intent. And what is entity? Entity is basically what particular thing you want to buy. You want to buy a mobile phone, which is iPhone. You want to buy a car, which is Mercedes. You want to buy a medicine. Okay. So all these are called entity. Entity is basically being used to determine what particular thing you want to deal with. Okay, what is that exact keyword you want to deal with? So intent is basically what you want to express, and entity is basically what you want to deal with. So this is all about intent and entity relationship. Okay, so now a particular intent, let's say a particular entity, let's say mobile phone. Mobile will be having multiple intent. Okay, so it will be having, let's say for an example, iPhone is there. Okay, iPhone X. Okay, iPhone, let's say I'm just going with some older version. Okay, iPhone 8. Okay, then you might be having Samsung. Okay, you might be having Redmi. Okay, these are some popular mobiles in India. So XYZ, okay, all these mobile phones. So each and every these are being noted as mobile phone. This particular process is called annotation. This particular process is called annotation. What is annotation? Annotation means these keywords are being referred to a particular category. iPhone X, iPhone 8, Samsung, Redmi. Whenever these keywords come, the model should understand that this means mobile phone. Even though there might be a spelling mistake. In spite of Redmi, if somebody writes Red M, it should understand that, okay, this belongs to a mobile phone. Maybe user has written a wrong spelling. So your model should be able to understand all those stuff. Your model should be able to do that. Okay. So this particular process is called annotation, and this is very, very tedious task. Okay, you will have a bunch of data set. You will have GBs of data set. Okay, generally those GBs of data set you need to annotate it manually. Okay, and that takes a lot of time, and you cannot automate this particular process because this is something you have to do it for any NLP related solution you want to build it. Okay, you cannot automate it. You cannot get it done automatically, okay, right? So this particular things is being done by subject matter experts. Okay, basically in the real time when you will be working as a data scientist or an ML engineer, you will not as a data scientist you will not annotate. Okay? So you will be having a domain expert. Okay, let's say you are building a chatbot, you are building a conversational AI platform based upon some let's say based upon some financial data. So you don't have that knowledge, right? What is the product name? What is that particular keywords? What are the particular keywords? You don't have that domain knowledge, right? So you will have the subject matter expert who have the domain knowledge and who will actually annotate these things for you. Because annotation is very tedious task, and you have to do that. Also, you need to classify between different intents. Okay. For an example, you want an order intent, so you need to classify order intent. You want to cancellation of order, so you have to make a cancel intent. You want to reschedule, so you have to make a reschedule intent. Now there is another type of intents like names, human names, right? For an example, Rishabh, my name. Okay, it is something unique. Okay, it's from India. I'm from India. So it's something unique, Rishabh. Okay. Maybe not relevant in US, maybe not relevant in UK, another part of the world. Okay, only India has some relevance. Many people have this name. Okay. Similarly, let's take another name, Mike. Okay, Mike. This particular word has no relation in India. Okay, none of the people have this kind of naming. Okay, this is basically waste pattern name. So, but people from UK, US, okay, they will be having this relevancy over there. So you should also train your intent based upon names, because you don't know there are multiple strategies to do that. One of the strategy is take the names as an entity as well as intent as an entity. Okay, so I will show you those strategy. Don't worry. At the end, I will show you. Okay. So this is more about intent and this is more about entity. So entity is what is that particular object. Intent is what you want to express. Okay. So this is the intent entity relationship. Fine. Any questions so far, anybody?
Sorry, Rishabh. So this annotation is a dynamic process, or is it a one-time process?
It's kindly one-time process, but there is a challenge in conversational AI platform. You will see your Google Assistant or your Apple Siri Assistant. Okay, they will say that I'm not able to understand what you are trying to say. At that point in time, what it does basically, it takes your entire context and get it stored into the Apple database and Google database. Now later on again, the team will actually work on that particular data set to improve their assistant. Okay. So it's a kind of, you can say, cumulative process for few of the companies like Google, Apple and all. And there are few companies like who only deal with specific thing, like Amazon only deals with order. Now it doesn't make sense to them if you tell something about music, if you tell something about video, doesn't make sense to them. Only the things that make sense to them is basically what you are dealing with an order. Okay. Dealing with past orders, okay, dealing with current order. You want to order something, you want to cancel. So those are basically been understood, like whether it is a part of a domain or not. If it is a part of a domain, domain means what you want to build it. Okay. So if you want like everything your conversational AI platform should know, then you are not building a correct architecture. you will fail in the meantime. Okay. But if you want only on a specific domain, the technique is you take a specific domain, order management, that is your domain, and your AI platform should be able to solve any queries from order management. That should be the strategy in order to reduce the amount of annotation.
All right, thanks. Clear.
Yeah. So this is all about intent entity relationship. Now coming back to this is one of the example. Okay, medicine is very ambiguous. Each and every word has no relationship. Sometimes it will have a relationship, sometimes it will not. All the diabetes is one of the common disease across the world. All the diabetes medicines will be having a similar name. If you just notice, sometime you can just think along those lines, because I have worked on medical data. Okay, so I have seen that all the medicine related to diabetes have a similar name. All the medicine related to nerve or the neural system have a similar name. All the medicine related to heart diseases, cardiac diseases have a similar name. So you can also categorize there, like those names are similar. You can categorize as a diabetes medicine. Those are basically coming from the heart, cardiac disease medicines. Okay, the names are similar. You can actually categorize again back with particular different category. Okay, like heart disease category. So like that also you can do it, but I should not prefer that, because that will again confuse your entire model. Your model will overlearn that. Don't overlearn and overfit your model. Okay, so that you actually fail in your real-time exams. Okay, you should not be too much confident. Okay, and failing in our real-time exams, it's more like you should be knowing that much. Okay, and should be answering in a proper way. So all this can be categorized as a medicine, but again, it is very ambiguous. Sometimes you might fail in understanding the particular category or particular medicine names. Okay, so you need to train with lots of data. You need to train with lots of data, or there is a strategy to solve this problem. The strategy is use your medicine database. So if you are building for any medicine application, use the database. Okay, the database which is containing all medicine names. Okay, so all medicine names should be there in that database. You just take it and mark as a category of medicine. So that is one of the good technique. Okay, that is one of the very good technique that you can use it for annotating the medicine category. So this sort of technique you can approach. You can use SQL. Okay, SQL or any type of NoSQL also you can use it. Cassandra, MongoDB. Okay, you can use all those type. So basically what I'm trying to say is you have to create your own entities. So this is the category called medicine. So there will be very ambiguous entities. So you need to be very careful while you are designing those type of entities. Fine. Let's move forward. Now coming to the next topic, which is more of a next topic is more about designing. Okay, designing our chatbot. So how will we design the chatbot? Okay? That is what we are more focused into it. Now this particular thing is a bit complicated. For those who have attended my session before, might be knowing this particular slide, and I'm just repeating for them. And for those who don't know, for them it will be a new slide. So it's basically how it behaves, how your mind behaves. In the same way, we try to generate mathematically in the same way. Okay. So for an example, for the first day when you see anything, okay, and if you see it with the full attention, then only you can remember for a longer period of time. If you don't see with a proper attention, just you want to ignore it, you will forget in next day, right? So similar thing is being carried over here. Okay. Similar kind of philosophy is being used by designing this sort of models. Okay. So what is RNN? RNN is basically recurrent neural network. Okay. Now what is neural network? So NN, we call it as neural network, artificial neural network, ANN. Okay. Now what is this artificial neural network? First point, it is similar, it's a biological inspiration of our neurons, okay, of our human neurons. Okay, we take those neurons and we try to implement it in a real time. Okay? So it's a kind of a biological inspiration that happens. It's called an ANN, artificial neural. So how does it relate? How does we structure them? So it's basically, there will be multiple inputs. These inputs will be actually being, okay, let me first make you understand a single input, then we can go with multiple inputs. So this is your input. This is your summer or the computation part. Okay. And this proceeds with some sort of activation function. And then it gives you a result, which is Y. This is basically your input. Okay. This is basically referring as a weight. And over here, it is basically weight into input. And this is being as B as a bias. So this is input, this is weight, this is bias. So the output which comes from here is weight into input plus bias. Okay. This is the output which comes from here and gets into this particular input of this particular function. So this is called your neural network. Okay. And from here, this is being the original function, the original output it comes is activation function into weight into input plus bias. So this is the formula for your neural network. Okay. So Y equal to activation function, weight into input plus bias. Now, what is weight in real time and what is bias in real time? So for an example, if I just relate with your real time studies, when you actually study a new thing, okay, when you try to understand, like today, we're trying to understand new stuff, we're attending a session, right? So you will be actually, if you are putting your full attention now, you will be able to remember this thing for few many years and days. Okay, you will be able to remember that somebody was teaching the conversational AI platform, and on that particular workshop, I was going through RNN, because you are putting your full attention. Okay. That attention, or it could be vice versa. It could be like you are going through the same material again and again, and you are getting it revised every time. So that particular thing is called weight. Okay, something which is attached to your emotion. Okay, it could be you are reading the same thing again and again before your exams. I believe that in my life I can able to remember the exam days and the day before the exam. Okay, because on those days I used to work very hard before the exam. I used to study, and obviously on the day of exam, okay, few of the exam, not every exam I can remember. Those exams which were very stressful, I am able to remember. Okay, or those is incident, okay, which are very emotional to you. Let's say you are going for a vacation. So that is particular, each and everything you can remember from that vacation, right? What food you have taken, what dress you have worn, okay, what activity you did it, everything you can remember. Why? Because that is very emotional. Okay, like in a human lifetime, okay, people not regularly go with those vacations, right? Somebody will be going like twice in a year, thrice in a year. Somebody will go every year. Okay, it might depend. So that's what you can relate your emotions as weight and there is some sort of biasness is there. So bias is nothing but it is kind of some force which allows you to do a specific task. Okay. Or for an example, when we are treating with the kids, right? When we deal with kids, we say that don't do this, don't do that. But the kids will turn up doing that thing only. Why? Because it's something very curious there about. Okay. That why somebody is telling me not to do that. Let me do it and see what will happen. Okay. This is the first thing. The second thing is they are not much aware that what might going to happen, what might happen, and their brain are basically biased because they want to do that stuff. Okay. They might not come into the curiosity. Okay. Very infant babies. Okay. They cannot have that curiosity because they cannot understand the language. It is because their brain is stimulating. Okay. They are doing that particular task. Okay. Because infants cannot understand language. It is similar as your neural network. You can treat an infant as a neural network, a newly born baby as a neural network, because they cannot understand anything. Neither they can hear at the very beginning stage, they cannot hear. Okay. Even though they can hear, they cannot understand anything. All the senses are working, but it cannot compute anything. While it experience with the environment, okay, they slowly come to learn those things. After a few years, they can speak. After a few years, they can full-fledged speak, right? They can be admitted to school and they started leading normal life. But initial 2 to 3 years of their for every human being is something which is kind of a learning, right? So it is similar like your neural network. So whatever you are taking, you cannot express anything, but you're taking everything as a weight, everything as a bias. Okay. So bias is basically when your weights and your inputs becomes 0, which is equal to 0, so your y is equal to sigmoid of b. Because weight and input is 0, 0 plus b will be some value. Bias will be some value, which will be like 1, 2, 3, or some value will be there for bias. It could be in decimal as well. It could be in float, whatever it is. So some value will be there for bias. So sigmoid is the activation function. It's called AF, activation function, which actually triggers this particular bias, given that your weight and input is 0. I want to give a very wonderful example. Let's say when you are in our school days, let's say the MCQ questions, right? Four options are there. MCQ, multiple choice question. 4 options are there. You need to select any one option. Okay. Now, let's say you don't know the answer. What you do? Just go around the question again and again, and whatever the answer you want, you feel that okay, this might be correct. Okay, I don't know, but let me just mark it. Those cases actually your weight and input is 0, because your weight is 0 because you are not aware of that particular question. Now, given that your input is your question because you are seeing it from your eyes, that is your input. Weight is basically 0 because you are not aware of it. So whatever input is coming, it is going in waste because you can read it, but you cannot compute it because you don't know about that particular question. So weight into input is basically 0. And then your bias factor comes, which is like your mind is saying, okay, mark A. A will be the answer. Okay, you're just tossing in your mind out of these 4 questions MCQ, which one I should take. So that is basically your bias. So weight into input becomes 0. B is basically your bias, and sigmoid is basically your activation function, which actually triggers this particular bias, which actually allows you to do so. So activation function example, let me give. For an example, you want to recall something, you want to remember something, okay, and you are not able to do so because you are trying to recall, but still you are facing some challenge. Slowly you are able to remembering. You are able to remember that particular topic, and then finally you are able to remember the entire day. Okay? When you are talking with your some friends, they gave some hint. With that hint, you started applying. So that becomes your input. when these inputs works with the trained weights, because it is already there, happened in past. Okay, let's say some event happened in past. Your friend is trying to interpret on that event, and you are trying to recall. Okay, you were also present in that event, but now you have forgotten it because it has happened in past for a long few years. But your friend remembered everything. Your friend is trying to make you recall on that. So in that point, what happened? Your weights actually helps. The bias helps. The most what it helps is activation function. It helps you to trigger. It helps you to trigger that particular memory. So this is all about your neural network. So over here in this case, RNN basics, what we did is we took all the inputs and we passed through all these inputs through this particular activation function. And here in RNN, what we are doing is we are taking this in a sequence. You can see the input of X0 and X1. It's a combination of X0 and X1. X2 is a combination of X2 and X1. X3 is a combination of X3 and X2, like that. Okay, so this is all about RNN. So why we are taking in combination and in sequence? This is because we are taking the input from the previous sequence. Let's say I want to study AI. Okay, so I want to study AI, let's say. I want, so in this case, what happens is I plus 1. In this case, 1 plus 2. Okay, this case, if there is a neuron here, okay, 2 plus study. So it comes in a sequence. Okay, actually what is happening is while we are at study, while we are at this particular neuron, you are having an experience of I want to, all these three. You are having all these three experiences. But in the meantime, for a very long sentences, what happens is the sequence is not able to remember very long sentence. As similar as human being cannot remember very long sentences. Okay, if I tell you a very short sentence, you will be able to remember it. Okay, but if I tell you a very long sentence, okay, you cannot remember it. If you just, for an example, if I tell you to only remember this line, they are the natural architecture of neural network. You can remember they are the natural architecture of neural. But if I say that the entire sentence, okay, try to remember this entire sentence, you cannot. Okay, it takes a lot of time. So that's what your RNN faces, this sort of problem. Okay, sequence issues are there with RNN. So the next step to solve this sort of problem is, let me clear, I'm clearing the diagram. LSTM stacks. So what is LSTM stacks? It is being inspired from RNN. Okay, but over here we are doing something different. Over here we are only remembering those stuffs which are important. We are just ignoring those stuffs which are not important. Okay, so it is similar as your RNN. So this is your RNN. LSTM is as similar as your RNN. Flow is similar, but here we are adding some extra mathematical computation which helps us to remember whether the particular sentence, which helps us to remember very long sentences. And why? Because it can help us to remember the long sentences, because the LSTM stacks uses a technique which is called forgetting technique, information storing technique, and the last technique is output layer. Okay, there are 3 layers to it. So let us understand each and every layer in a more detailed way. So as I told that the formula for neural network is weight into input plus bias, and this is called activation function. So this is your neural network, right? So over here HT minus 1 means this is HT minus 1. This is HT minus 1, and this is basically CT minus 1. T minus 1 means LSTM is actually goes with time. Okay, LSTM goes with time. Why it goes with time? Because the appearance of sentences comes with time, right? For an example, let's say I want to have burger. For an example, I want to have burger. I want to have burger. Burger will, if it comes at the beginning, burger I want to have. Does it make any sense? No, right? burger I want to have. Does it make any sense? No. I want to have burger. That makes sense because burger is coming at the end, have is in between, and want is at the beginning, right? So similarly, the sequence has to be there. Okay. In text processing, in NLP, what lacks is while we pre-process the entire data set, the sequence get lost. If I remove the prepositions, if I remove all those particular things, the sequence get lost. So in order to solve that particular problem, we use LSTM stacks, LSTM core, okay? So that each and every tokens comes in a sequence, we accept the data in a sequence, and then we actually learn from that sequence, which is important, which is not important. But sequence is important. So that's why T minus 1, and this is basically T plus 1. So you can refer this as T plus 1. This one. This is as HT plus 1 and this as HT minus 1. So the first one is FT is equal to sigmoid weight into input plus bias. So there are two inputs, XT and HT minus 1. This goes through this particular sigmoid activation function. So I'm not going into too much detail. What is sigmoid activation function? Just remember that it helps to trigger. Okay. So this particular thing is called FT. Okay. And then becomes IT. Okay. So what is IT? This is IT basically. It takes the same. So this part of the LSTM model, this part of the LSTM model deals with forgetting. This part of the LSTM model deals with information storing. And this part of the LSTM model deals with output layer. Okay. So forgetting means whatever is important, we'll only take it forward. Whatever is not important, we'll forget. So that is being defined by the weight. That is being defined by the previous input and current input. So that is called weight into input plus bias. And then it passes through an activation function. The next stage is IT is equal to the sigmoid function weight into input plus bias. So it also takes the same thing and it passes to the multiplier. So we have a multiplier here. And you can see there are two activation functions. One is sigmoid and another is tan H activation function. So these two activation function helps, one of the activation function helps to remove the unwanted substance. This particular activation, this particular IT is helping to remove the unwanted substance, and CT is actually helping to remember to actually wide up. Okay, tan H actually is helping to wide up the entire data set. Okay, wide up the entire data set means it's basically the weights. Okay, the weights has to be the range of weights is between -1 to 1. Okay, -1 to 1, whereas the range for sigmoid is between 0 to 1. Okay, so 0 to 1 is basically helping. So probability works with 0 to 1. Always remember this. Probability models work with 0 to 1, whereas weights work with -1 to 1. Okay, so this tan H weights. Okay, tan H works with -1 to 1, and sigmoid works between 0 to 1. So 0 to 1 is basically squeezing. Okay, -1 to 1 means I am opening, I am widening up my weights. Okay, so the tan H is actually giving an opportunity to widen up my weights. Okay, and then we are multiplying IT into CT. This is the multiplier. Okay, and then we are actually adding up with this particular thing. So this is multiplied FT. So FT into CT -1 plus IT into CT. So this is the summary. FT, this is FT. FT, let me just draw it a different color. This is FT, right? FT into CT -1. Okay, this one plus IT into CT means this one. So we are actually over here. So what does this signifies? This signifies that anything which are not relevant will be removed, and only which are relevant will be remembered. The next thing is triggering layer, means output layer. So this particular output comes from here, goes to this tanh, and then it gives us the output for the next layer. Okay, so tanh gives us the output for the next layer. While output, it takes the sigmoid again. Okay, whichever is not required and whichever is important, we'll take that, as well as whichever is remembered. So both the things are coming. So it's like I want, both is coming. I and want. I is over here. Want is coming from this particular remembering unit. So I and want both is coming in this particular stage. So that's why the old one as well as the new one. This is the new one and this is the old one. Okay, this is the old one. New one, old one. Both are coming and giving a new input for the next layer. I want to. 2 is the next layer. Okay. Then in the next LSTM, next to next will be I want to have, right? Next to next will be I want to have. Next to next will be I want to have burger. So like that, there are different modules, there are different tokens. There will be different sequences. Based upon the sequences, these LSTM stacks behaves accordingly. So this is all about little bit more in depth I went. Okay, just to make sure understand this. These are basically covered in 2 days. Okay, LSTM and all in our course. Okay, so now coming back to this, let me show you the code now. Let us go back. Let us go back to our coding, and a lot of theory we understood. Now let us focus on coding. So while the code is being there, let me open the notebook. In between, any question, anybody? So this is our Django chatbot. So we have done a chatbot based upon, we have implemented in Django. Okay, so there are multiple things in it. There are 2 components basically. Let me explain. So one of the component is this, the other component is this. So this component is basically the Django component. This component is basically the AI component, you can say it as. Now, what is Django? For those who are not aware of Python Django, Django is basically a kind of a framework which helps to create a web-based module in Python. Okay, so it's kind of a UI and all those things can be easily created, can be hosted. Okay, it's a kind of an API which helps to transact between the web-based models. Okay, so in our course, we actually go with how to implement in Django and all those stuffs. So Django is helping us to implement all the our conversational AI platform. Okay, and then we have a Rasa bot, which is basically an AI platform, and which is our AI code. Okay, where we have actually coded the neural network and all the stuffs. So now So the training and all those annotation, you can understand annotation is very difficult task. So it takes a lot of time. So let me show you the data set first. So NLU.yml. So this is where your actually data set will be stored. So this is how you need to annotate your data. So you can see that NLU greet, these are all your greetings. Okay. Then you can see that COVID, I have taken a COVID as an example. Okay. So in this, we have, since COVID is very booming currently, so we are taking a chatbot which can help in all the COVID related queries, but it is not full-fledged because it takes a lot of time to get it developed. Small use case I have taken. So you can see these are something, these are our intents. Okay. I am infected with COVID. I need COVID vaccine, COVID protocol, COVID vaccine, third wave, second wave. So in India, it is like second wave, we have almost completed. So assuming that there will be third wave, I'm not sure, but I hope that there should not be any third wave. It should back to normal. So lockdown activity imposed at Delhi, night curfew at Bangalore. Okay. Total lockdown at Kolkata. Lockdown has been declared during weekends. And in fact, I am infected with Delta version of COVID. I'm not able to take vaccine due to the recent infection of COVID. So there are so many types of very less amount of data I have taken. Ideally, you should take a large amount of data. So very less amount of data, and how many entities? So where are the entities? These are our entities. COVID is basically your intent, and these are your entities. These are your entities. These are your entities. This is my entity. Okay. This is my entity. So we have two entities, disease and activity. So lockdown, curfew, and all those things are being referred as an activity. COVID is being referred as a disease. Okay. So this is basically intent. Intent is COVID, and these are my disease. Disease and activity, these are my entities. Okay. Clear, guys? So this is how you have to deal with your data set. It's a very tedious task. You need to build this data set. It's very annoying stuff. But yes, this is very important to do it. Affirmative, deny, mood great, mood unhappy. Okay. So these are the data set that you need to build it. Okay. The next part is, this is called NLU.yml. The next part is, let me hide this, stories.yml. Okay. So these are not codes. These are basically YML files. Okay. So stories.yml, what does it says that what bot will say initially, let's say what human being is saying, human being is greeting. What bot is saying that, chatbot is saying that utter greet means you also greet. This is the name of the function. Okay. Utter greet is the name of the function. Then intent is mood greet, means I am happy, I am unhappy, all those sort of. Action is try to make user happy, utter happy. So these are basically the name of the functions. So these are basically stories. Now let's see COVID story. So you can see this is story COVID. Intent is COVID. Action is action COVID. Okay. So this is an action. Now what is this action COVID? What is this utter greet? Let us see now that part. Okay. So stories are there to build. Stories helps us to understand the different scenarios, right? If you want to order something, what is the first thing you need to say? But the first thing you need to say is what is that object you want to order? You want to order a medicine, you want to order a mobile phone, you want to order XYZ, whatever, what is that thing you want to order? The next step is what is your address? The next step is what is the time that you want to get that order delivered? And the third and the final step is what kind of payment you want to do it. Online payment, offline payment. Okay. So this is your flow. This is called story. This is being referred as story. Story help us in building the overall concepts. Okay. Now coming back to those functions, right? So there are two types of function. One function is straightforward. Like over here, it is being referred as utter greet. So text is, hey, how are you? Okay. So if you say hi, the bot will say, hi, how are you? Here, the responses are pretty much straightforward. Okay. So this is because for hi, the response what it will be. It will be how are you, or you can create multiple text. Okay. You can create different responses and you can pass those responses through loop. Okay, and this domain.yml, what does it mean? Domain.yml, it is kind of a domain for your chatbot. Okay, it is like the entire thing should be present in this particular domain. You can see a lot, all these intents are present over here. Then all the entities are present over here. Okay, disease, activity, these are all our entities. So domain.yml helps us to list out all the intents and entities. Okay, the next step is, once we have this, what will be the solution for dynamic responses? Okay, what will be the solution like for COVID, right? It could be anything. It could be, let's say I can ask, is there any lockdown? I can ask that I want COVID vaccine. So is there any lockdown in particular city? We'll have a different answer. Whereas I want a COVID vaccine needs a different answer, right? So what should be the structure for dynamic responses? So for that, you have to come, we have created this action.py. So in this action.py, you need to write a code, okay, Python code. So what the Python code does over here, I'll just go through it. The Python code first takes the intents, okay? It takes the intent, whatever the intent is coming, it takes that intent. Then it takes the entities, okay? Intent and entities. For a given line, let's say I want to buy iPhone. So my intent is order and my entity is iPhone, right? So that these two things are important. So similarly, in this case, I am infected with COVID. So it means that intent is COVID and my entity is disease, COVID as a disease, right? So if you see that if entity is equal disease, then response this. If entity is equal activity, then respond this. Furthermore, you can drill down, like if entity is equal, if entity disease has certain value, let's say COVID, what type of COVID virus you are infected with? Are you infected with mutant 1 virus? Are you infected with mutant 2 virus? Are you infected with mutant 3 virus? So you can further drill down. First is, let me just draw it and show you. At first it is entity, okay? It is entity. Then what is the value for entity? Let's say value for entity is COVID, okay? Then if it is COVID, then what type of virus you are infected with, okay? So it's basically Delta or mutant 1 or mutant 2, like that. So what sort of virus you are infected with? So entity is COVID. Then these are the sub entities. Okay, these are also entity. These are the sub entities. Okay, and again for this particular delta, you can create a response like this. Conditional if condition, you can use it. For this particular things, you can create a response. Okay, for this particular entity, you can create a response. So like this, you have to prepare the action code, which will run as an action server. Okay, so all these will be there. The last thing that you have to do is you need to train the model. Okay, we have created the intents, we have created the entities. For each and every intent and entity, you have an action in place. So now is you have to train the model. So let us train the model. Let us see, training takes a lot of time, few hours it takes. Okay, so I already have trained in order to save that time. Otherwise, if I want to do it real time, it takes a lot of time, few hours it takes. Okay, so let me show you how to train it. So we have to write a code, trainer.py. So we took all these files, domain.yml, we took it. We took the data, means nlu.yml, okay, stories.yml. and we took the config. So config.yml contains how to get it interacted with Django server. So Django server is running. With Django server, how can we get a interaction? I will show you the config file. Let me show you. So these are certain configurations. Okay. So these are the configuration. Okay. What kind of algorithm we are using? White space tokenizer, regex featureizer. Okay. Then you have count vectorizer. Okay. Mix grams, n grams basically. So these are the different features. Also, you have the endpoint.yml. So endpoint.yml is using this particular URL. With this particular URL, all the communication will happen. The actions which we have done, right? The actions which we have coded, that action will be communicated through this particular endpoint URL. Okay. So let me show you in real time. How does it look? And at first, let us go through this trainer thing. So this is basically the trainer.yml. You just run this, the model will train. Okay. The model will get trained. Once the model is trained, you will get the model in, you will get a checkpoint. This is called checkpoint. Okay. What is checkpoint? This particular thing is called checkpoint. What is checkpoint? Checkpoint is nothing but your weights. Checkpoint is nothing but your weights. I mentioned, right? Weight into input plus bias, right? So your weights and bias is basically your checkpoints. Okay. That is what it has to be stored. Next time, whenever you give the input, it will get computed into weight into input plus bias. It will traverse through all those LSTM model, and then it will give you the answer. Prediction will be coming. So this is all about your model. Okay. So this is how the training happens. Now let me show you in real time. Let me create the 3 different server, and then let us run and see in real time how does it works. So I'm closing all this just to be on the safer side, and let me go to the CMD. So I'll go to the particular path. If I do a dir, I get all the folders and files which is present in that path. So first go to this rasa bot and then dir. So these are all the files which are present. So what we need to do is we need to run the server. So we need to run 3 type of server we need to run. Okay. So let us run that. Let me widen up this. So this is what we need to build it up. Debug -debug. Yeah. So this is the first server I will be starting it. It will take some time to start. In the meantime, I can start the other 2 server. So one of the server is action server. So we have seen that action.py, right? Action.py we have seen. So that server we will start it. So cd downloads cd. I'll just go to this path. Okay. Path where okay. So just do dir. You will be able to get the manage.py. Okay. So this manage.py, let me show you that as well. Manage.py. What is written over there? So this is basically my Django one. So over here, we have to write the HTML code. So this is index.html. So in this index.html, I have actually used React component, React.js component. So let it get loaded. You will be able to see the React based component. Okay, fine. Just hold on. So this is the code, okay, HTML code. We have taken this HTML code from the React server, okay. So it's more of a React.js, okay, which is written in this particular scalable, in this Amazon AWS, it is present, okay. And we are using this particular host, okay, local host, because in real time, what will happen is you need to provide the IP address, okay, where you want to host it. Currently, we are using the local system, so local host. Okay? So this is how your UI looks like, okay. And let us see and run and see what happens. So let me close this. So this is my server, which is already running an app. Okay, this is the server. See, these many packages it interacts with. So it's a very heavy one. Okay, the code is very heavy. Obviously, this is coming from server, so it will be a heavy one. So finally, what we need to do is we need to also host the Django server. And we need to also run the action server. So this is basically the action server. Okay. So almost let the action server come up, then we can see it in our UI, in our Chrome. Okay. Okay, fine. So our action server is also there. This is my server. So this is the IP address where it will be showing. So let me open that. So this is the platform it looks like. COVID help bot. Hi, I am COVID app. I help you with all sort of queries. You can write hi. Hey, how are you? I'm not good. It says here is something to cheer you up. Okay. Shows a small picture of tiger. Okay. I want to get COVID vaccine. I want to get COVID vaccine. So this is the Indian site from where you have to register yourself, and then you will get a call for a vaccine. Okay, you will be able to schedule your vaccination. So this is the site, government site. So it helps us to give this particular answer. Now I want to know, is there any lockdown at Kerala. Please contact your local police station for lockdown related queries. Kerala is something which I haven't trained with, but still it is able to understand this particular sentence. Okay. So this is how you can actually deploy your chatbot. Okay. And you can get it. It's a kind of a solution that you can build it. So now it is with a very less amount of data. That's why it looks like very simple. But in real time, this could be very powerful if you build it with a lot of business logics, okay, and a lot of data set. So now open to any questions. So let me know if you're having any question. Anybody, any question? You can also build that as well. It can. Okay. You can add those APIs. Okay, so over to Kunal. Kunal, are you there?
Yeah, I'm here.
Great. So over to you, Kunal.
So are we done with this? Are we done with this session?
Yeah, we are done. So any questions, please let me know on chat. Okay.